Today we're going to start chapter 2. First section is derivatives and rate of change. We're going to define certain terminology. Let's start with the definition of a tangent line. What is a tangent line? A tangent line at a point P. Point P has two coordinates. The x value, which is a, in this case we say the point A, and the corresponding y value f of a. So this is the point P. We say the tangent line at that point is the specific line that has this slope. This definition is for the definition of the slope at that of the tangent line. But what is the tangent line? Tangent line at a point is the line that touches, let's say this is the point A with the y value of f of a. So it's the line that touches the graph at that specific point. This is the definition of a tangent line, is the line that touches the graph at one point. It's not the line that crosses. It's not like this. In some cases this might happen, but basic definition is that the line touches the point on the graph. Okay, so here let me introduce the idea of the slope for the tangent line, because this is what we're going to talk about. Slope of the tangent line at a specific point. Let's assume we know this line, this red line is what we're looking for. We're looking for the slope of this line. This is the question. If we know the slope of this, then we can create the equation of the tangent line. So to figure out the slope of the tangent line, we start with assuming that there are 2 points. One is the point A and f of a. The other point is the point x and the y value of f of x. And if we connect these 2 points, we get a line. I extend this line, and then we have a slope for this line. We can calculate the slope of this line by simply saying the change in y divided by change in x. So I can say here, let me write here, the slope would be f of x, the change in y, minus f of a, divided by change in x, x minus a. This is the slope. But if I pick the point x very close to a, let's say if I pick the x here, let me use a different color to make sure you can see difference. Okay, let's try blue maybe. Okay, so if I pick the point here and draw the tangent line through the point A and that new point, what do I get is somehow the line would get closer to the actual tangent line. The slope would be, now this is, let's say this one was x1, let me call it x1. And then here we have the point x2, and the y value would be f of x2. So what is the slope? The slope is still this formula, the change in x, the change in y, which is f of x2 minus f of a, divided by change in x, x2 minus a. And if you compare, what happens is the formula stays the same. It's only the x values that are changing. You have x1, x2, and if I continue this process and create a closer point, what do I expect is that the line that I will get will be closer and closer to that red line, the tangent line. So what can I say is the slope is basically this definition, that the change in y divided by change in x, assuming that the x value is getting closer and closer to a. So the change in y divided by change in x, and we pick this x value to get closer and closer to a. That's what we want. It could be from the other direction. I didn't pick point from the other direction of the curve, but if you do that, you still get the same result. So this is how we estimate the slope of the tangent line. This is the expectation of what will happen. So this is the limit, will tell you what you would expect to get. So the slope of the tangent line could be defined through this definition of the change in f of x minus f of a divided by x minus a as you let the limit x approach to a. So the x is the variable, a is a fixed point, is a fixed x value. There is another way to define this. It's very similar. So look at the other graph. Let's say you pick 2 points. In the last time I picked x and a. Now, what if I say the distance from a is the point a and f of a here, What if I say the point, the other point that I'm going to pick it with a distance of h from A. So I'll pick the next point here, which would be A plus h, whatever h is. Let's say if h was 1, this point would be A plus 1. That would be the next point. So I'm going to call it h. And what would be the y value? The y value would be corresponding f of A plus h. So if I define the slope now for this new line that I've created, the slope would be f of x plus h, the y values, difference in the y values, not x, sorry, f of A plus h minus f of A divided by A plus h minus A, the difference in the x's, A plus h minus A. A plus h minus A would be simply A. So the slope turns out to be this formula, f of A plus h minus f of A divided by h. And if you see, this looks familiar because we call this the difference quotient. We discussed this last time in the chapter 1. We calculated this difference quotient, and the reason was for this specific topic. Now, similar to the last part, when we let x get close to A, what we can do in this case is, if I want to figure out what is the slope of the tangent line, I want to figure out the slope, what I can do is I can let the h be smaller. Instead of being such a large number, I can pick h to be this small. So what would be this point? This point would be A plus the new h, would be kinda closer in terms of the curve, the two lines, the green and red line would be closer. And you see that the trend of the blue line, green line, and we're going to get closer and closer to the red line by doing this. But the formula would be exactly the same thing. It would be f of the change in the, this here would be f of x plus h divided by f of x plus h minus f of x divided by h. Difference in the x values would be simply h. So what we can do to figure out m is just similar to the last part. Let h be smaller and smaller and smaller. H does not approach to A. What is happening to h is you started by picking h to be 1, then you pick it to be 0.1, then you pick it to be 0.001, and so on. So what you do is you let h to be 0 almost. So what we're saying is that the definition of the slope could be defined this way. Difference quotient, or what you can do is let the h approach 0. So there are these two definitions. They both give you the same result. Either way, you will get the same result. I try to do examples to show you that the result will be the same. I will calculate through different ways. So here's an example. Given this function f of x, x squared plus 3x, we want to find the equation of the tangent line that passes through this point. So what we need is, you're already given the point. So what we need is to figure out the slope of the tangent line, since we're looking for the equation of the tangent line. And how do I calculate it? You can use either formula. So I'm going to use limit f of x plus h minus f of x divided by h as h approaches to 0. To me, this is the easiest formula compared to the other one. I'll show you the other way as well, but this one is easier because you don't really need to factor out stuff. Try to know all the factors. And this formula is the general formula. Sorry, not x, A. A is a fixed value. In this case, for us, this is A, is the x coordinate. It's 1. So A is given 1. F of A is what we know. It should mean, if you replace 1 into the function, what do you get is 1 squared plus 3 times 1 should be 4. This is exactly this point, 1 and 4. Okay, so what we're trying to calculate is the slope. So I'm going to replace the A and say I'm trying to find out what is f of 1 plus h minus f of 1 divided by h as h approaches to 0. So limit, let's figure out what is f of 1 plus h. F of 1 plus h would be, replace 1 plus h into the function f. You'll get 1 plus h squared plus 3 times 1 plus h. and then minus f of 1. What is f of 1? F of 1 is simply 4. We already have that. This is the corresponding y value. This is f of 1. So minus 4 divided by h as h approaches to 0. Now, raise 1 plus h to the power 2, distribute the 3, see what we get. Limit h approaches to 0. There we go. 1 plus h squared would be, what is 1 plus h squared? 1 plus h would be, I'm going to skip through the steps. It would be 1 plus 2h plus h squared plus 3 times, distribute this 3 as well, plus 3 plus 3h minus 4 divided by h. Okay, I'm going to cancel out some terms. 3 and 1 are 4, minus 4 will cancel out. You have, so m would be equal to limit. You have h squared plus 2h plus 3h, 5h, divide by h as h approaches to 0. Now you can factor out an h and cancel it out. So it would be limit h times h plus 5 divided by h. These two will cancel out as h approaches to 0. So it would be similar to limit h plus 5 as h approaches to 0. And that is simply replace 0 for h, you'll get 0 plus 5 equal to 5. Okay, so here I figure out what is the slope. Slope turns out to be 5. Okay, can I find the equation? Let me write the equation as well here. The formula for equation of a line, y minus y1 equals mx minus x1. This is the formula for equation of a line given the slope and a point. So therefore, I hope you guys remember this. Y minus the point, x and y given 4 equals slope is 5, x minus 1. Here's the equation for the tangent line. You can distribute the 5 and move the 4 to the other side to get y equals 5x minus 5 plus 4 minus 1. The same thing. These two are the same. Okay, the important part is that you calculate the slope correctly. After that, you just replace it into the equation of a line. So we found the equation of the tangent line that passes through the point 1 and 4. Okay, here's another example. You want to figure out what is the slope of the tangent line. At this point, it's given at 1. But I'm going to calculate it through another formula. The other formula. So here is, they ask you to figure out this limit. What is this limit? If you compare it, this is exactly slope of tangent line at x equal to 1 for the function f. You replace 1 in the function f, it would be f of x minus f of a. A is 1 divided by x minus a. So here, let's try to calculate this formula. This example. So what we get is limit. Okay, sorry about that. I cannot draw a straight line. Here we go. Still not good. X approaching to 1. Okay, what is f of x? F of x is 2 divided by x plus 1. Again, you can use the x plus h formula, but I want to try to show you both methods. Minus f of 1, replace 1 into the function. You'll get 2 divided by 1 plus 1. This is 2 divided by 2, which is simply 1. Divided by x minus 1. As x approaches to 1. So I need to calculate this. If you replace 1 into the formula, you will get 0 over 0. So you have to simplify this first. So let's try to simplify. There are multiple ways to simplify this. I recommend first do common denominator in the numerator. So what you get is 2 divided by x plus 1. You do that step by step as well. Minus. I'm going to write 1. I'm going to multiply 1. Since I want to make common denominator, I'm going to multiply this by x plus 1 over x plus 1. This way I have the same denominator. So what do I get is minus x plus 1 divided by x plus 1, and denominator is x minus 1 as x approaches to 1. Okay. Limit. Don't forget the limit notation, x approaches to 1. Now they have the same denominator, x plus 1. Numerator is 2 minus x plus 1. 2 minus 1 would be 1. You get minus x as well. And divide by x minus 1. At this point, again, if you replace 1, the equation becomes 0 divided by 0. So it's not possible, so I have to continue to simplify. What you can do is now look to see if you see similar terms. I'm going to show you that the numerator is, if you factor out the negative from the top, what you get is negative x minus 1 divided by x plus 1. That's the same thing. Negative x minus 1 is the same as 1 minus x. Distribute this negative into it, you will get x 1 minus x. Why did I do that? Because I see similarities now between the numerator and the denominator. I can cancel out these two terms. So what do I have? I have limit negative 1 divided by x plus 1 left. There is nothing else left. Numerator, there is negative 1, denominator x plus 1. As x approaches to 1. What do we get? Negative 1 divided by x plus 1. If you replace 1 into it, you will get negative 1 divided by 1 plus 1, which is negative 1/2. So what did I calculate? I found out the slope. The slope is negative 1/2. This is the slope of the tangent line. If you want to find the equation, first you need to find out what is the point. The point is given x equal to 1. What is the y value? The y value is replaced with 1 into the function. What is f of 1? That would be the y value. So it would be at 1, and f of 1 is 2 divided by 1 plus 1. What you get is 1 and 1. So you have the slope, you have the point, you can find the equation. The equation would be simply, in this case, it wasn't asked, but I want to write it so make sure that everyone knows. Y minus y1, so y minus 1 equals, the slope is negative 1/2 times x minus 1. Again, you can distribute and move stuff around. Okay, so now, again, this is optional. Which method do you want to use? You should get the same result. For me, it's easier to use the first one, f of a plus h minus f of a divided by h. But because there is no need for factoring terms like this. There is no trick. There is no necessity for tricks. You would have only one term in the denominator, and that's h, always. So that would be simpler to use than this method. Okay, one more definition. We want to discuss this important definition, derivative of a function. Derivative of a function, f, at a specific point a. We say, we can rewrite this definition instead of keep saying derivative of a function f at a point a. You can use notation f prime of a. This dashed line is to show that this is the derivative of the function f at the location a. We say this is the derivative if you have the same quotient formula as h approaches to 0. So what does it tell you? In both methods, since they are the same result, you can use either one. So what does this tell you? This is f prime at a. So it means that f prime of a is exactly the same as the slope of the tangent line at the point a. So if they say the derivative of a function at the point a, they mean that the slope of the tangent line at the point a. This is the definition of the derivative is exactly the same as the definition of the slope of the tangent line. So they are both calculating the same thing. Derivative of a function at the location a, it's the same as saying the slope of the tangent line at that point. It's not the equation of the tangent line, it's the slope of the tangent line. That's what I want to make sure that you guys understand. So here, given this example, find f prime of 2 if the function is given square root of x. So what we want to do is, I'm going to use, again, the x plus h is easier. So I want to find out what is f prime of 2. So it would be limit as h approaches to 0 of f of a plus h. So in this case, a is 2, f of 2 plus h minus f of 2 divided by h. as h approaches to 0. Limit h approaches to 0. What is f of 2 plus h? It means into the function f replace 2 plus h. 2 plus h instead of x. Minus f of 2, it would be square root of 2, divided by h as h approaches to 0. How do we simplify this? I mentioned this last time that you multiply by the conjugate 2 plus h plus square root of 2 if you want to simplify this. Square root of 2 plus h plus square root of 2. It's the same term, but the opposite. You want to get rid of the square root. If you distribute, again, you should distribute term by term to see what you get. If you do this, I'm going to do this again, just to make sure that everyone follows with the steps. Okay. The numerator becomes square root of 2 plus h times square root of 2 plus h. We'll get square root of 2 plus h squared. Square root of 2 plus h times square root of 2, you'll get square root of 2, square root of 2 plus h. You don't need to multiply them. Just write to this first time, then you try to simplify it later. Negative square root of 2 times root 2 plus h would be negative root 2 plus h. And negative root 2 times root 2, it's negative root 4. And I'll divide by h times this term. Square root of 2 plus h, 2 plus h plus square root of 2. And you notice that I didn't distribute the h because I want to cancel out that h somehow. This h in the denominator, this causes the denominator to be 0. So I don't want to distribute it. I want to keep it in a way that hopefully it will cancel out with the numerator. Okay, let's continue. Cancel out the terms that are similar in the numerator, opposite of each other, these two. Exactly the same terms, but opposite. What is square root of 2 plus h squared? The square root and square root will cancel out, you get 2 plus h. And square root of 4 minus 2. And I'll divide by h times square root of 2 plus h plus square root of 2. You see these two now cancel out, and what do I have is h divided by h will cancel out. So simply you will get limit 1 divided by square root of 2 plus h plus square root of 2. H approaches to 0. And you might again ask why we didn't get rid of the square roots. The question was not to get rid of the square root. The question was to make sure that there is no 0 in the denominator. So this whole process was to get rid of that h in the denominator to make the denominator 0. Now if you replace h with 0, what you get is 1 divided by square root of 2 plus 0 plus square root of 2. What is that? That is square root of 2 plus square root of 2. So you will have 2 square root of 2. So what was f prime of 2? Is 1 divided by 2 square root of 2. This is our answer. What does it mean that f prime of 2 equals 1 divided by root 2? That means the slope of the tangent line, at the point x equal to 2 is 1 divided by 2 root 2. I want to make sure that you guys understand what we're trying to talk about. If they ask you for f prime of 2, that exactly means the slope of the tangent line at that location, at x equal to 2. Okay, so here, just to make sure we know what we're talking about, is the slope of the tangent line at the point x equal to a. This means the same as f prime of a. That's what I've been saying right now. There are a couple of more definitions. Average rate of change. Rate of change is the change in y divided by change in x. Change in y, you can always show it as f of x2 minus f of x1 divided by x2 minus x1. That's how we calculated the slope originally. We estimated by calculating this difference. This is the average slope. So that means if you're given 2 points on a curve, you can connect those 2 points. It will tell you the slope. The slope is going to be the average rate. It's like an average estimation of what will happen. Okay, so this is the average value. Average rate of change would be the given 2 point x1 and x2. you can calculate the slope of that line connecting these two, this line segment. Instantaneous rate of change means you're only given one point, and what we care about is not the behavior of the function later on, but exactly at that point. So that means find out the slope of this line. So instantaneous rate of change is another way to say the derivative at point A. It's another way to say the slope of the tangent line at x equal to A. It has the same formula. Limit f of x2, limit f of x minus f of a divided by x minus a, or you can use this, instead of a, you can use x1, because you want to be consistent, these two. But you can still, again, use a in the formula as well. I'm going to stick with that f of x plus h, f of a plus h, because it's easier. So average rate, you find the difference between the y's, divide by the difference in the x's. Instantaneous rate, slope of the tangent line, and the derivative, they're all the same, and you use either of those two formulas that we had. Here's an example of the average rate and compare it with the instantaneous rate. This is very common in business. If you take business calculus, these stuff will show up more often. They're not the cost of, so here look at the example. The cost of producing X units of a certain commodity is this function, Cx. C stands for the cost function. So cost function is given as this formula. It doesn't really matter what the cost function is. We don't really care about that at the moment. What we want is to find the average rate of change. In the cost function, when you produce, when the level is changing from 100 unit to 105 unit. So there is a cost from 100 unit to 105 unit. We want to find out what is the average cost in that time for those amount of units that change. So here, what we're trying to calculate is, you can say this is x1, this one is x2. Okay, so what we're trying to calculate is C average. Maybe I should write C average. It's the same as the average rate of change. It would be f of x2 minus f of x1 divided by x2 minus x1. You notice there is no limit, because these two numbers are not approaching to each other. You have two values, you want to find their y value, two x values, you want to find the corresponding y values, find out the slope of that line connecting those 2 points. So what would be the range? Just replace 100 and 105 into the calculator, find out what is f of 100 and f of 105. So I'm going to try to do this as fast as I can. I should have prepared these numbers already. Sorry, give me 1 second. Let me see if I can find the calculator. Okay, so it'd be 5,000. It'd be 5,000 plus 10 times 105 plus 0.05 times 105 squared. This is replacing 105 as an x2 into the function c, and minus 5,000 plus 10 times 100 plus 0.05 times 100 squared. So if I calculate this, this would be f of x2 minus f of x1 divided by x2 minus x1. x2 minus x1 would be 105 minus 100. I don't know why I picked such a big numbers. This was maybe one of the examples in the book. That's why I picked it. Okay. Okay, so I can simplify it a bit. These two will cancel out. 10 times 105 minus 10 times 100 would be 50. So there is a 50 there. Plus, I'm trying to avoid the calculator, but I think at some point I will need it. 0.05 times 105 squared minus 100 squared would be 5 times 205 divided by 5. Okay, these numbers that I'm writing here is just I'm trying to create a shortcut for myself to calculate without using the calculator, but I think at this point I might need to use the calculator, so let me do that. 50 plus 0.05 times 5 times 205. It becomes 101.25. This becomes 101.25 divided by 5. So divide by 5, it gives us 20.25. So this is the average cost of, I should have said the cost per dollar. Okay, this is dollar amount. This cost is dollar amount. So here it would be $20.25. This would be the cost in average for every unit that you add on. Okay, now if you look at the instantaneous rate at 100, that means if you want to move from 100 unit to 101 unit, not exactly to 101, but if you want to move from the 100 unit up or down, you will estimately you can calculate what would be the expected rate of change. So that is what the instantaneous rate of change would be. So sometimes they call it the marginal cost. This can call marginal cost. And what does it tell you? It's basically, do you want to calculate C prime at 100? This is the question that we want to answer. That is the instantaneous rate of change. The instantaneous rate of change would be limit f of I forgot the f function, c of x plus h, in this case c of 100 plus h minus c of 100 divided by h as h approaches to 0. That means replace 100 plus h into the c function. You'll get 5,000 plus point, was it point? No, it was 10 times 100 plus h minus, plus 0.05 times 100 plus h squared. Now minus c of 100 minus 5,000 plus 10 times 100 plus 0.05 times 100 squared. You got to calculate these numbers and subtract them from each other. There's a bracket. Means that negative sign is for the whole thing. All divided by h. And I forgot the limit. Limit as h approaches to 0. I'm gonna skip this step, but you guys can calculate these numbers and multiply, subtract them from each other. And I'm gonna go ahead and say, okay, there is a shortcut. We'll talk about it later. It would be, the result would be, it would be 10 plus 0.1 times 100. That is 10 plus 10, so you'll get 20. So that means the cost would be $20 if I want to move from 100 unit to 101 unit. Not exactly at 101, but at the moment of the, when the unit is 100, when we have x 100 unit as our x value, the instantaneous rate would be $20. So that would be the cost that we expect. Okay, this example is kind of the basic of what you might see in business. So I wanted to mention this example, but there are other types of examples. Hopefully you will see similar examples in the homeworks. But the instantaneous rate is the same as f prime at that point. So don't mix it up with anything else. Average rate is just the change. There is no limit involved. Okay, I'm going to stop at this point and continue.